For question 5, a rectangular piece of cardboard of 18 cm wide and 30 cm length is used to construct an open box. So we have a shape here, which is a rectangle shape with the length is 18 wide and 30 length. So 13 length and 18 wide. Then the question says, a square of side X is cut out from this corner. So they're going to cut out a square here with the length of X. So from this corner, so they're going to cut out from this corner and this corner so that they can build a open box. So by bending this side up, so when you bending it up, we can get a rectangular box, open box here. So here is the folding part. Here will fold up. Here also will fold up. Here will be also fold up. So can build out a open box like this. So the first question they ask us, show the volume of the box is equals to this expression. So when it fold up, we can see our length original 30. When it cut off these two square, so our box here fold out is equals to 30 minus 2x. And then our length here, our width here, original is 18x. Once it's cut off this square and this square, so our length here, our width here, leaving 18 minus 2x. And then the height of the box is equivalent to the square that it cut off, which is x. So from here, we have to show out the volume as this result. So volume of a cuboid, it will be equals to the length times its width and then times its height. So we're going to expand this 30 times 30 times. So we can expand it in, or we can expand it this 30 times 18 540, and then this one 30 times negative 2x negative 60x, then 2 times 18 36x, then plus 4x squared times x. So here we can simplify it to become negative 96x, and then times x becomes square. So finally we managed to show this. We managed to show the volume of the box is this expression. Then our next task is find the dimension of the corner square, means find out what is our x, so that this volume is maximum. So we're going to maximum this case. So use the equation, use the formula that we found this, and we're going to differentiate. We are going to differentiate our volume with respect to our variable x here. So this will give us 540 minus, so power move to the front, power minus 1, and then power move to the front, power minus 1. So after we differentiate it, we will let it equal to 0 to find out the critical value. So we let it to 0, we simplify our quadratic here. So this quadratic can be simplified by 12. It will give us x squared and then minus 16x. Then we rearrange the quadratic here in order to help us to factorize. So you will notice that we cannot factorize this quadratic. So we can use another method. We use formula where x can be equals to negative b plus minus square root of b squared minus 4ac over 2a. So we'll still get our answer critical value, which is 12.36 and 3.64. So after getting our critical value, we're going to use second derivative test to verify this critical value. So we're going to differentiate v with respect to x again. So this time will give us negative 129 plus power move to the front 24x. So we try to substitute when the first critical value x equals to 12 minus 12.13, 12.36. So our d2v dx squared will be equals to, so positive concavity outwards. So it will be a minimum case. So another critical value that we get here is x equals to 3.64. So we verify it with our second derivative test. So we get negative. So concavity downward, this is our maximum case. So the question asked here is, find the dimension of the corner square where the volume is maximum. So the maximum case is this. So our x that can build out our corner maximum is equals to 3.64. So this is the dimension of our box. So the dimension of the square is equal to 3.64 times 3.64 because it is a square, which is equal to 13.25 cm square. So this is all cm. So that's all for these questions.